Okay, good morning everybody. So I have taken the freedom to kind of change the title a little bit or kind of focus the content a little bit different what the title says actually. So I will be concentrating on manufacturing these measuring systems or devices, what kind of special features and challenges do we see in those, because that is the kind of expertise that our company has and is continuously doing. So first I will shortly introduce Oplatek, what we do, and then go through some specific manufacturing requirements or challenges and some conclusions at the end. So the company is more than 30 years old, and we have quite a wide customer base. More than 100 companies or customers are buying something from us every year, and most of them seem to be pretty happy what they get. That's of course very good for us. We have about 45 employees, and our turnover was last year, it was 4.5 million. Our expertise is in optics manufacturing. We have a wide range of capabilities in-house. So we are molding glass optics, different kind of components, lenses, prisms, so on. We are making thin film coatings, both metallic coatings and dielectric coatings, like filters, mirrors, and so on. Then we have our own workshop, CNC machining. We do ourselves there. Most of the metal and plastic parts we are manufacturing ourselves. And then we have 2 fiber drawing towers. We are drawing silica fibers and doing a lot of work around fibers. And we have also a workshop for glass. So we are grinding, polishing glass to some extent, cutting glass, using sheet glass also as a material, and so on. So pretty kind of versatile and kind of unique combination of capabilities what we have there. And what we do is we are providing customized products for our customers. So it can be components, modules, devices, but all have the common denominator that they have some kind of optics inside them, or they are part of some kind of optical system. And we are specialized in manufacturing, so basically we are a contract manufacturer, but we are also doing R&D, prototyping, testing, productization, of course. It depends on the customer, so if the customer don't have the resources or time to do those things themselves, they can buy the service from us. Okay, then that was in a nutshell what we are doing. It's also the basis or kind of background for these comments or what I've listed, challenges I've listed here. When we think about manufacturing of optical components, optical devices, or whatever. By the way, those pictures which are in these following slides, they are kind of examples of products that we are manufacturing in our production. But of course, the first challenge is normally the design, and when we are talking about optics in this kind of pulp and paper industry area, for example, so the robustness is probably the most important thing there. Sometimes those circumstances and people who are dealing with those devices, they don't always kind of are aware. They are not aware of the sensibility of those things, and so everything has to be kind of very rugged and different kind of structures which really you can use as a hammer almost and things like that. And of course in the design side, easiness of assemble whatever we are providing there, that is the very key thing, because in process industry, nobody wants to use lots of time assembling and kind of wasting time in something else than just producing. Then of course we have to remember different kind of design rules, which these lists are not exhaustive of course, but I have kind of taken certain things which we in our company see frequently, and they are always a kind of a topic of a discussion. We are talking about optical fibers, so bending radius is always a challenge. People and mechanical designers especially, they don't realize that fibers cannot be just bent like copper wires, and that can be sometimes very challenging to kind of really make something happen which a designer has easily made a drawing that the wire or the cable goes here and there, but then in practical world it's really not doable like that. Different kind of tolerances of course are always important. In thin film coating, ion beam is used to make very stable coatings, so we are getting rid of the excess water in the structure, and we are getting kind of a more dense coating by using an ion beam system, which we have in our thin film coating system. Backscattering is always a kind of a thing which you have to remember when you are designing the optical path. What happens there? What do you want to do with the light? Where does it go when it doesn't go to the right place, and so on. Then of course quality specifications are always important. Scratch and dig in our case, when we are making grinding, polishing, those levels which can be reached, they have to be kind of mutually understood with the customer, that what makes sense, and in this kind of aspect also kind of over quality is not of course the one we want to do, because normally it means also expensive solutions. So the quality has to be good enough, but not too good if it is not really required. Flatness is always a question in optics in many cases. Then of course light transmission through cable, through any kind of optics. What does it transmit? What is the absorption? And then of course aging, different materials aged in different ways, and those things have to be remembered when we are putting things together. Okay, then in the pressure, in the process, of course, many times the pipings, whatever there can be high pressures also. We need hermetic sealing, fusing, gluing. For example, in the optical cables that we manufacture, or fiber bundles, the ends of those have to be very cleverly designed so that we can go into the high pressure tubing or piping without creating a kind of risk in that connection that it would kind of break in some special circumstances. Different kind of movement or vibration in the process industry, when there are big engines running continuously, they always create some kind of vibration or movement, and it has to be taken into account. It can be solved, those problems can be solved by material selection. We can use strain relief, like in cables, for example. If we are scanning something, cable is doing back and forth movement all the time. Then of course isolation, putting something soft in right places may be the solution. No loose components, that's of course obvious. All kind of things can be done. Then mechanical wear in our case also is very frequently encountered in the process circumstances. There are in the pulp and those pulp and paper raw materials, you say. So we have also these additives which are being used there, and they are wearing all the materials, whatever you put in there, some kind of pipe or whatever it is wearing there in the process. So we can use very hard materials like sapphire. We can use some kind of hard coatings, of course, in some cases. We don't want to leave any that kind of edges which easily kind of are influencing to the flow, for example, which is passing by. So there are different ways of tackling these challenges. Then, of course, in that kind of process circumstances, magnetic and electric interferences are frequently encountered, and actually the optical fibers themselves are a solution in some cases, that you don't use copper wires or any other cables, but fibers are insensitive to these magnetic and electric interferences, and to use them in a proper way is many times the best solution for those challenges. Then, of course, when we are talking about optics, we are using some wavelength of light to detect or to lighten something. So ambient light, which is not the kind of a which disturbs the situation there in, for example, during the measurement, it can be a problem. We can use different kind of coatings also in those sometimes, or pulsed lightning or detection principles, so that if we have an ambient light but we are pulsating the signals there, then you don't kind of see the ambient light affecting to the actual measurement situation at all. Blackening, putting things inside enclosures, of course, maybe sometimes a kind of a obvious but also a difficult solution, but sometimes you just have to do it because there isn't any other way to keep the ambient light away. Then in the process conditions, especially pulp and paper process, there's always lots of water and high moisture in different situations, and you have to tackle also with that. So, for example, we have done optical cables in which the customer has then used air blowing inside the shed of the cables to keep the moisture away, because in optical fiber, one of the worst things which can happen is that the fiber directly gets influenced by water. If there are some micro cracks which may appear in the fiber, especially if you bend it, and bending and those more micro cracks, and then if you have water in there, normally means that end of the life will happen sooner than you expect for that cable. Then using some kind of isolating materials, for example, inside a cable, gel filling, for example, we have done to some cables. That is one way of keeping the water out there, so that you fill it with some material. You know that is not a problem, but it prevents the water getting in at all. And then, of course, some kind of heated things like, for example, coatings. If we have a window, we want to see through in every circumstances, and there is the tendency that the water is kind of appearing on the surface there. So for example, heating that window by using a heated coating material like indium tin oxide is one example, or otherwise kind of getting heat to that window is one alternative. Then, of course, in the process conditions, dust and dirt is always there in the air, and it always accumulates in wrong places, and all kind of self-cleaning surfaces, hydrophobic or some other kind of surfaces which don't kind of allow the dirt stick and or at least they are easily removable. The dirt can be easily removed by using some mechanical system, or, for example, using light, which basically kind of interacts with the material on the surface, so that there is a chemical reaction or something like that, which then cleans the surface after that. Okay, then we have chemicals. They are always present also in pulp and paper processes, and there we need to use protective coatings, some materials which are kind of not influenced by certain kind of chemicals, gold, sapphire, and so on. pH requirements may be sometimes very difficult. We are going from really very low pH to very high pH in different process circumstances or situations. Different kind of material choices. There we have to use enameling, metal glazing, for example, or something like that, to prevent this pH to really influence with the wrong in the wrong place. Then, of course, temperature can be a challenge. Again, different materials are a good way to kind of tackle that. For example, in optical fiber, we can use polyimide coated fibers, which can go up to 300, even 400 degrees continuous temperature. Glues or any other materials which are kind of graded to high temperature glues, they can go up to 150 or even more. But all these things have to be kind of understood, that in which situation you need to use these kind of special materials, because normally anything special is again also a bit more expensive than the normal quality. Again, air blowing, water cooling, of course, are obvious solutions in temperature problems or challenges. Okay, there was quite a list of different things that we have encountered in our production. That's not an exhaustive list by no means, but and I'm sure that the following speakers who are talking about specific measurements in pulp and paper processes and so on, they can say a bit more about these challenges. What I've seen in our kind of operations and work with our customers, that kind of supply chain management is actually a key thing in making these solutions and making them work also. There has to be a kind of management and a very good communication throughout through the whole chain, so that all these suppliers who are involved, they really understand that at what kind of situation, circumstances this measurement or whatever it is, it should work. And open communication, discussion with the customer and all the suppliers is kind of the key thing here. I would say that when an engineer gets some money and enough time, almost anything can be solved. But if you don't know that what is the challenge, what is the real situation in the process or wherever you are there doing some new measurement or thing, how can you solve that? There's no way. Okay, by these remarks, I would like to stop. Thank you.
Thank you, Jyrki. Any questions from the audience?
How do you qualify and validate your sensors with your end customers? Do you self-certify that with the customer, or do you also use an independent laboratory?
It depends on the customer and what is the requirement. Sometimes they want to get sometimes they want to get the kind of outside some kind of a statement or whatever that this has been done according some rules, or there is some standard we have to follow and so on. But I would say that in most of the cases, the customer himself basically knows what he wants, and he defines that what are the and what is the performance he is expecting, and we just have to show to him that it does it. Yep.
Do you have any software? How do you determine that the sensor is going bad so that you can do preventative maintenance or replace it so that it's not used to leak bad information? But how do you calibrate in a 24/7, 365 cycle to make sure the sensor is working and then determine when it's not working and then you need to replace it?
Well, actually, that is more maybe to our customer side who is doing that, because normally what we are doing, we are kind of supplying parts or modules or assemblies to the devices which the customer is then kind of finalizing and making the design, doing the software, electronics, all that. We are mainly dealing with optomechanics and optics. So if there is some specific part in that measurement or whatever, which really you can say pinpoint that this part is coming from your kind of responsibility, it's your responsibility, and it should work like this, and we can follow it, what happens, how the numbers are changing and so on. Okay, then of course we will do that. But in most of the cases, what we have supplied is only a part of the bigger system, and basically customer has the ways of following that and seeing if something goes wrong. And of course, if then the customer is kind of interpreting that the reason why something went wrong is partly ours, so then we have a discussion again that what went wrong, what we can do better, how do we change something, and so on. That's the normal kind of interaction with the customer anyway. So.
How do you expect your work to change in the future? What's the growing trend, or what is the product that has more and more demand in the future, or is that confidential information?
Yeah, well, quite a lot of what we do is kind of confidential because it's only between us and the customer, and we are not disclosing things which can be identified and so on. But
what type of products, can you tell anything?
Well, if I think a little bit, what has happened lately is for example, lasers seem to be, that business seem to be growing continuously. It's actually pretty fast actually.
Okay.
And that is there are new ways of using lasers in different kind of applications and so on. And overall, I think optics, photonics is very much a growing business. In many industries, new applications pop up, and I would say that it's up to us to kind of take the opportunities where they are, and if we are clever, we can also grow. There is no specific obstacle there. So if we are just clever, we can do it.
Sounds like a good strategy for me. Yeah. Excellent. Any more questions? Okay, thank you, Jyrki. And